Welcome to Mathematics. Today we're gonna do the integral of cosine of Ln(x) from 0 to 1. And you know, cosine of Ln(x), sine of Ln(x), they can be integrated, right? But we're gonna use our u sub, and then we're gonna use our let me just try to use our u sub. This is the first way to do this integral, and we let our u is equal to Ln(x) like that. And then I would like to get our original. We see on both sides e to the u is equal to x, and then differentiate both sides, you get u e to the u times du is equal to dx. So overall, put 0 into Ln(x), you will get this approaching to negative infinity. So this negative infinity. And then put 1 into Ln, you get 0. So overall, let me just write e to the u times cosine of Ln(x). Ln(x) is just u. And here is the deal. E to the u cosine u, you can remember these two formula. Integrate e to the u sine u du in the u world. This is equal to 1/2 times e to the u sine u minus 1/2 times e to the u cosine u plus c. But this e to the u cosine u du is equal to 1/2 times e to the u sine u, but this time is plus 1/2 times e to the u cosine u plus c, like that. But if this question is an exam question, you cannot just put down the answers, I think. You just skip a lot of steps. Right? So here's the deal. Whenever you integrate e to the u cosine u, just no constant. Just e to the something times cosine of something. Any variable? Here's the trick. I would like to write this twice. The same integral twice. Add them up. Don't forget about the du. So, because I don't like to write another one to integrate this on the right hand side, because this is a repeating situation. So, I would like to write as 2 times. But this plus this integral is just 2 of them. So, we're gonna multiply by 1/2 to be sure you get the original back. So, overall, here's the deal. Here, we're still gonna use integration by part. And here, we're gonna differentiate e to the u. And then integrate cosine u. And then differentiate that, you get e to the u. Integrate cosine u, you get sine u. So overall, you just get, this is first part of the answers, e to the u sine u, and then minus the integral of this, minus the integral of e to the u sine u du, like that. And don't forget about the lower limit and the upper limit. For the second one, we gonna differentiate cosine u, and then integrate e to the u here. Differentiate cosine u, you get negative sine u, negative sine u, and then integrate e to the u, you get e to the u, like that. So overall, this time that is the first part of the answer is just plus e to the u times cosine u, and then going from negative infinity to 0, don't forget. And then negative times negative, you pretty much just get positive. The integral of d to the u sine u du. And you will see this negative and this positive. These two integrals, they cancel each other. And that's nice. So overall, you just evaluate this from 0 to negative infinity. First, here, put 0 into it. Sine 0 is 0, e to the 0 is 1. So 1 times 0 is just 0. And this one, put negative infinity, sine of negative infinity, and is an indeterminate form, because it's always between -1 to 1. But thanks to the e to the power of u here, because if you put negative infinity, this is just 0. So over 0 times a number between of -1 to 1, you pretty much just get 0. So subtract 0 here. And then here, put 0 into it. Cosine 0 is 1, and then e to the power of 0, you get 1. And then here, put negative infinity. This is just the same as sine, the same situation as sine and cosine. So over this, you will get 0. So minus 0. So over 1/2 times 1, you will get the answer to this integral is 1/2. And the second integral is fun. No, the second method, still the same integral. Here's the deal. I would like to add another integral. It's still going from 0 to 1. I would like to add I times sine of ln x. Here, you will see why. Because the integral they are going the lower limit from lower limit to upper limit, they are pretty much the same, so you can combine them. So you get cosine of ln x plus I sine of ln x, like that. So over what is this? So over you can use use Euler's formula, cosine of something plus I sine of something. You get e to the power of I something, so you get e to the power of I ln x, like that, dx. So overall, you can put I into the ln, so e and ln, they will cancel each other out, so you can get x to the power of I dx. Integrate x to the power of I from 0 to 1. So over you will get, first you add 1 to the power, so 1 over I plus 1, and then multiply by the new power, it's I plus 1, and then you evaluate from 0 to 1. And here's the deal. I doesn't want to be on the bottom. I want to be on the top. So let me just simplify. I plus 1 over I plus 1, just follow the order. So over, I'm going to multiply by the conjugate of it. So I minus 1. So over the top, you'll get I minus 1. And then here's the deal. I plus 1 times I minus 1, you pretty much just get I square minus 1 square. So I square minus 1 square, you'll get -1. I square is -1, and the minus 1, you get -2. So over you get -2 on the denominator. So over you can switch the sign thanks to this negative, so it becomes 1 minus I over 2, like that. So over you get 1 minus I over 2 times x power of I plus 1 from 0 to 1. So over, here's the deal. Put I into it, 1 into it, 1, 2 into the x. 1 raised to any number, including I plus 1, I plus 2. You still gonna get 1 here. So over you get I minus 1 minus I over 2. And second, minus, put 0 into it. You just get 0 here. So over you just get 1 minus I over 2, like that. So over 1 minus I over 2, we can split it to 2 parts. So over you get 1 over 2 minus 1 over 2 times I, like that. And here's the deal. Original question, this cosine of ln x from 0 to 1 plus I sine of ln x plus 1. We know that this cannot be 0, right? Because we have an I here. If this is 0, we are not gonna get an I here. So over the solutions, just compare to the original one and the answers, so you can get the integral of cosine of ln x dx is equal to 1/2. Just the same as this. And then the integral of sine of Lnx dx. Just remove the I, so far you get -1/2 like that. It's really cool. Right.